Hi, welcome to today's video. Today we'll be looking at the remove linked list elements algorithm. We are currently going through the lead code patterns by Shem Prashad, and I hope we do enjoy this video. If we find it helpful at all, please subscribe, like, and share the video. Thank you. So the remove linked list elements algorithm actually just says that given the head of a linked list and an integer val, we are to remove all the nodes of the linked list that has the value that we are given. So for example, and then we are to return the new head of it. So for example, we are given a node of 1, 2, 6, 3, 4, 5, 6, and we are given a value of 6. So everywhere we see 6, it is removed. So it becomes 1, 2, 3, 4, 5, as we have in our linked list. And where it was empty, we return an empty linked list. And where everything, for example, from the head to bottom, everything was 7. So, and we have to remove 7, so we remove everything, and then we have an empty list. Okay, so we are told that the number of nodes can start from 0. So it's possible to have an empty linked list like the second example here, and we have it up to 10,000 items. Okay, and the value will always be within the range of 1 to 50. Okay, and then our value that we are to use to check across will always be between 0 to 50. Okay, so basically let's see how we can solve this algorithm. So we are given an algorithm where we have we have 0, we have 1, 2, 3, I think we have 6, 4, 5, we have 6, and then we are told that the value is 6. So we are to remove everywhere we have 6. So basically what we just need to do, we just will go through our list, and everywhere we check 1, is this 6? No. So we go to the next. Is 2 6? No. It goes to the next. Is this 6? It goes to the next. So it says, is this 6? Yes, this is 6. So what we have to do is to say that this is no more the next, that the next, which is going to be, which was 6, will not more be 6, but will now be 4. So it's now be, so our 3 will no I mean 3 will no longer have a next of 6. The next item after this 3 will now be 4. So we go again. So from 3 we go to our next. This is now our new next. We say, is 4 equals to 6? No. So we go, is 5 equals to 6? No. Is 6 equals to 6? Yes. So we break this tie again, and then the previous, which is 5, will now be equal. So the next will be null. Actually, they will now be equal to what is here, which is going to be null. So we come back again. Since we have broken ties with this 6, we now go to the next, which is null. And since it's null, we know we're at the end of our loop. So basically, I think this is how we can go ahead with this. Okay, but I am seeing a scenario. So imagine where we had 6, 6, 6, 6, and then we had 1, we had 2, we had 6, had 3. Let's just give it something random. Let's say 6, let's say 5. So in this situation now, if we go with this approach, so let's say we are here and we say, okay, this is 6. So how do we cater for what was in the previous? So it means that, okay, so what we could do is, okay, we could have at the beginning, we could check for if this is 6, for example. So if this is 6, this is where our head was at the beginning. If this is 6, we say this is no more the head, we make this the head. We say, is this 6? It is 6, so we say this is no more the head, we make this the new head. So is this 6? We say yes, we make it, we cancel it out, we say it's no more the head, we make this the new head. Is this 6? We go, and then we continue until we get to a place where we do not have 6 as the head. So for example, 1 is the head here. And since 1 is the head, we can now go ahead with this our approach we used earlier. So I think that's what we would have to do to cater for that edge case. Okay, so let's try and put it code and see how it looks like. So we say that initially we will have to go through the linked list to remove any item that is at the beginning that is equal to that value. So we want to just say while the head is not equals to, we want to be sure our head is not null, and we'll want to check if our head, the value is equals to that. So for example, like in that situation, we are checking if 6 is at the head. So if 6 is at the head, we want to make the head to be what is in the next item. So we want to keep doing this until we get to a point where we have 6 as not the head, or where if everything, for example, is 6, then head will now be null. So either of those situations, we want to continue until we have one of those two situations. Okay, so what we could have is, okay, so let's just have, let's say currently we are at the head, and then let's have a previous, which is also going to be at the head. So we know that my head will definitely, because where I am now, I know that my head is not equals to that value because of the previous code I have done here, this logic that we have from this highlighted part. So it means that what I could just do is just, I know that, so while the current is not null, I could just check if my current, the value, if it is, so I know for the first item it will definitely not be val, so I have no fear of that. So because of the initial check I had done, so I could just check the previous dot current. So basically, what I am sure that this previous will never be null, and this previous will hold an actual value because it will never be the head. This current and previous will never be the head and head, because I am sure that that first value which is at the head will never be equals to the val, because we have eliminated all the items from the head at the beginning that could be have that potential value of 6, for example. So if we have this in this situation, but if not, we just say our previous is equals to our current. So basically what we're just trying to say, okay, so if, so basically, if as we are going through, as we are going through here, this was the current and this was the previous at the beginning. So what we do when we came here, we said this is not equals to 6, so current and previous at the beginning. So when we went to this, our current is now here, and we are asking, is this equals to 6? No, we now make our pointer for our previous be this also. We go to the next item, we say this is where we are currently here. We say, is this equals to 6? No, so we move our pointer here. But when we go to this or this 6, we say this is where we currently are. We said, is this equals to my previous? I mean, is this equals to 6, the value? Yes, it is equals to. So you see, I do not move my previous. As you see, what we do is we say our previous dot next. So you see, so we say our previous, the next for our previous, which is our 3, the next for that previous is no more going to be 6. We set it to our current, which is 6, the next after that one, which is 4. So basically that is why you see I am having this same, the previous, if it finds a value, I want the next thing after my previous to be the current value, which is equals to 6, the next item after that. Basically, that is the idea behind that. And then after this, I just want to say my current is going to, so basically just moving to the next item. So whether or not we find a value that is equal, we want to always move to the next item. So basically, and then when we are done, and just return our head, because we are definitely sure that this head is either null or it has a value that is not equal to 6. So that we are very sure of. So we can just submit this and see what we have there. So okay, everything will run fine, and then we can now submit and see if we are able to pass. So basically we just go through the logic again, and we see that, sorry, 1 minute. Okay, so basically what we are doing here, we are eliminating any item that is in the head that is equal to that value, so that it helps us with what we want to, we're just catering for one of the edge cases where the beginning of the linked list could be to have those values. And then after that, basically we're just going through the loop, our while loop, and we're just checking if we find the item, then we want to make the next of the previous to be the future item. And otherwise, I just want to make my previous now be what is in the current, because when I go to the next item, what was current before will be the previous. So basically, that is just the idea behind it. I hope we did understood this. And if there's any question or we want clarity on anything, you can drop a comment in the comment section and I will definitely respond. See you in the next video. Do make sure you like, share, and subscribe. Thank you.